For my digital story, I'll be telling the tale of my third graders learning how to measure to the nearest quarter inch. They need to rely on their background knowledge of fractional parts to help them understand how a ruler is like a fraction bar. We discussed examples of when we would need to measure and what units to use. Students were told that they would be measuring more precisely because sometimes you need a more exact measurement. The lesson followed the information processing theory of learning. The fixed body of knowledge to acquire was precise measurement to the nearest quarter inch and identifying that mark on a measuring tool. I helped my students to activate their prior knowledge by telling them to think about what they already knew about fractions. Students used a ruler at their seat and pointed to their best guess as to where the quarter inch mark was. Only a couple students actually knew. I thought it was best to backtrack a little to identifying the half-inch mark. This one was more recognizable and gave my students a strong starting point. Piaget identified these 4 concepts that lead to conceptual change in a new learning situation. My students would need to adapt their current understanding in order to better understand precise measurement. When not all students made the connection between a ruler and fraction bar, I realized they were experiencing Piaget's disequilibrium. The problem was twofold, and here are my 2 twists. 1. Each student had a different previous understanding of fractions, which underlie measurement on a ruler. 2. I needed a new teaching strategy. Just having students point to the quarter inch mark based on what they knew about the half inch wasn't working. My students experiencing assimilation took their existing structures of measurement and fraction bars and combined them to find the quarter inch mark, and they were then in equilibrium. The new information balanced with what they already knew. Those not in equilibrium needed to accommodate their existing structures of a ruler and of fractions and make new connections. They found themselves unsure of how to proceed towards an understanding of precise measurement. Those students who were not able to accommodate the new learning were now experiencing disequilibrium. The balance of their learning was off as they were still unsure how to find the quarter inch mark. I would need to try other strategies to help my students understand how a ruler can be divided into fractional parts. We took paper rectangles and folded them into fourths. This hands-on activity kept students actively engaged while making visual representations of fourths. They were starting to see that fractions come in more than just circles divided in half, and the fraction bar looked like a ruler. Another strategy I used was having students draw lines to a certain point on the ruler, like 1 1/4 or 2 3/4. Equilibrium finally occurred for my students. They finally understood how fractional parts can be found within inch marks on a ruler, and this happened through tapping their prior knowledge and changing up teaching strategies. They put this learning together to understand how to measure precisely with a ruler.